He's got it done.
The thing about question 6 that was frustrating was how many people were within striking distance of the right answer and didn't follow through sorting out an equation in the right way. So just people who just didn't work the algebra out. That was it, over and over again. So what have we got here? Two particles, A and B, constant speeds, and they collide. Coefficient of restitution is E. After collision, A and B continue in the same direction with new speeds. Find U and M in terms of E. So I did my little diagram I always like doing for these. So here we've got a before and after. Here they are, A and B. The question has told us that that is 4 and that is U. That's 0.2 kilograms, that's n kilograms. Afterwards we've got that one with 4, 1 minus e plus e squared, and this one is now 4. So, this question is all about restitution. We've got e in there, we've got to do things in terms of e. So let's start with my restitution equation. E is the speed of separation divided by the speed of approach. So the speed of separation, that one must be bigger than that one, otherwise they wouldn't be separated. So it is 4 minus 4 lots of 1 minus e plus e squared, divided by the speed of approach. That one must be bigger than that one, otherwise they wouldn't be approaching. So it's 4 minus u on the bottom. So I'm going to start with that equation, see what I can do with that. Actually, from there, if I multiply both sides by 4 minus u, I get 4e minus eu. U is 4 minus 4. Oh, let's multiply out the bracket, shall we? Yes, let's. 4 minus 4 plus 4e minus 4e squared. My 4 minus 4 conveniently disappears. I like factorising things. What do I want to find out? Stuff. I want to find out u. Right. Let's see if we can get that on its own. Well, actually, this is great, isn't it? 4 minus 4 is 0. If I take 4e away from both sides, I've got minus eu is minus 4e squared. I wanted to find out what u was. I can divide by e, because e can't be 0. So we've got u is 4e. If we divide through by e, there we go. Great. That was finding u. And it's amazing how many people had this equation and just didn't kind of get there algebraically to get it to simplify to that. But it doesn't take much, does it? Now, we need to find out m, don't we? So we need to think of momentum. If we're going to bring m into this, we need to think about momentum. That's what we always do with these kind of equations. And so the total momentum before is equal to the momentum afterwards. So that is before we've got 0.2 times, what was that? 4 plus m times u. Afterwards, we've got 0.2, so equals 0.2 times 4 times 1 minus e plus e squared plus m times 4. So that's where we are with our momentum equation, conservation of momentum. And I now just need to work out the algebra that's going on here. I've got 0.8 plus mu is 0.8 minus 0.8e plus 0.8e squared plus 4m. That's where we are. Well, great. 0.8 I can subtract from both sides. I'm wanting to find out what m is, so I'm going to bring all the n things over to one side. So let's get rid of that 0.8, that's gone. I've got nu, take away 4m, is 0.8 e squared minus 0.8 e. I want to find n. So I've got that, which gives me n as 0.8 e squared minus 0.8 e over u minus 4. Now a few people got that far, but that's still not there. It said find n in terms of e, and that's not in terms of e. Oh, but hang on, u equals 4e. I already knew that. So if I replace u with 4e, and let's see if we can factorise this and see what happens if we work on that. We've got 0.8e as a factor on the top, times e minus 1. On the bottom, we've got 4e minus 4, but if we factorise that, that is 4 brackets e minus 1. At which point, my e minus 1 cancels out as a common factor. I'm left with 0.8e divided by 4, so m is 0.2e. That's my answer. It's only the first part though. That was 6 marks. But can you see how actually setting up the equations wasn't difficult? It was just messy, massive algebra to wade through to get to some sensible answers. Now, find the value of E for which the speed of A after the collision is least. And find in this case the total loss in kinetic energy due to the collision. Right, oh well, the speed after the collision, the speed of A after the collision, A's speed after the collision is, I want that, it's actually 4 times that, isn't it? Well, hang on. This thing here is a quadratic. And it's a U-shaped quadratic at that. It's a positive coefficient of the squared term. How do I find the lowest point that the quadratic can take? I have a few ways. I could complete the square and find where the vertex is. But I'm living in a post-core 1 world, so I can also differentiate things. I'm happy with that. If I differentiate with respect to e, 1 minus e plus e squared, I would get 2e minus 1. Sorry about the order that I've done that. Differentiate e squared to get 2e, and minus e gives me minus 1. I want to know when this is a minimum. 2e minus 1 would be 0. So it's when e is a half that I get the minimum value. That's frustratingly simple, isn't it? So, at that point, u equals 2, because u equals 4e. Yeah? From earlier on, I found u is equal to 4e in the first part of the question. And 4 times 1 minus e plus e squared, well, that happens to give me a minimum speed of 3. 1 minus a half plus a half squared is 3/4, isn't it? That's 1 minus a half is a half, plus a quarter is 3/4, times 4 gives me 3. And m, which is 0.2 times e, is 0.1. So I've now got figures for everything that's going on here. The kinetic energy before is, well, beforehand I had 0.2 times 4, so that's a half 0.2 times 4 squared, half mv squared, remember, plus a half m, which is 0.1, times u squared, so that's 2 squared. That gives me 1.8, is the kinetic energy before. The kinetic energy after is a half m, and I've got it as being 3, haven't I? So that's 3 squared. Plus a half times m is 0.1 times 4 squared. I was told it was 4 afterwards. And that is 1.7. And I think we can see from that that the kinetic energy lost is 1.8 minus 1.7, which is 0.1 joules. That's how much we've lost. Okay? Oh, it's all going great. Part 3 said, find the possible value of E, values of E, for which the magnitude of the impulse that B exerts on A is 0.192. Okay, so we backtrack now. All of these things that we worked out have gone again. We're back to finding a different value of E now in part 3. Find the magnitude of the impulse. Impulse equals change of momentum. So I'm going to use an impulse as change of momentum equation. It's the impulse that B exerts on A. So this is going to be, our impulse is 0.192. And I'm back to here. So I'm doing, if I look at A, if I focus on A, I've got 4 times 0.2 as the momentum before, and the momentum after is that times 0.2. And that's B's exerted. That must have been lost at that point, wasn't it? Because A has slowed down in this collision. It must have done, because B is at the same speed. So that is, my change in momentum is 4 times 0.2. That's the initial momentum of A. Take away 4 times 1 minus E plus E squared times 0.2. That's my final momentum of A. And the thing that has changed this momentum of A is the impulse exerted by B on A. So that's how it all ties in together. This, again, it looks complicated, doesn't it? But if we simplify this, we get 0.192 is 0.8 E minus 0.8 E squared. And it does look horrible. And you're thinking, these are really nasty numbers. And then you think about, hang on, it's just a quadratic. It looks like that. And many of you have calculators that are confident enough in their own self-image to be able to take a quadratic equation and give you the roots of it. Those of you who don't have calculators that are up to that need to come up with a strategy for dealing with this. If we divide through by 0.8, for example, you get E squared minus E plus 0.24 equals 0. At which point you might feel that you could do something with this. Or you could think of this as being, let's multiply by 50, which gives us 50E squared. This was what I was thinking here, to try and get this to something I could factorise. Of course, you could just go straight to the formula here, and there's no, I was just trying to think, could I actually factorise it neatly? I then thought, I can divide by 2. You can tell I was enjoying myself at this point. I was thinking, can I factorise that? Well, yes, I can. If I go 5E and 5E, and go with 3 and 2, and they would need to both be negative, wouldn't they, to give us a plus there and minus there. That would work, wouldn't it? That gives me minus 15, minus another 10 is minus 25, and that gives me plus 6, giving me E is 2/5, E is 3/5, equals 3/5 as my solutions. Bingo, there we are. Tremendous, great work, Dave. There we go, 4 marks for doing that. It was a bit of a messy quadratic, and you know, you basically got 2 marks for solving that quadratic, which is, we're doing this as AS students, aren't we? We haven't even done the exams in Core 1 and Core 2 at this point, so it's a bit mean to be asking us to do all of that. But anyway, there we go. Stop the break.